Sir, you are not audible.
Unmute kara.
Thank you.
You are not audible.
Please check, sir. Am I audible now?
Okay.
Yes,
Okay.
now.
Okay.
Yes, audible.
Okay. Thank you, Dr. Solanke. It's my great privilege to introduce you with today's keynote speaker of this multidisciplinary one-day National E-Conference on Socio-economic and Ecological Impacts of Climate Change with special reference to Indian Subcontinent. We have today's keynote speaker, Dr. Priyadarshini Karve, with us. Just I'm introducing herself. Dr. Priyadarshini Karve has completed PhD in the subject physics from University of Pune. Her first research project resulted in the development of process for converting the agriculture waste into the charcoal. The technology work, the Ashton Award for Renewable Energy in 2002. In a career spanning more than 20 years, Dr. Karve invented a number of improved biomass burning cooking devices to reduce smoke in the kitchen and dependence on firewood for domestic cooking in rural areas. She has worked on the decentralized organic waste to fuel technologies. She developed a methodology for technology selection and promotion to improve adoption of clean cooking energy devices by end users. In past 5 years or so, her work has focused on devising and promoting strategies for low carbon and sustainable urbanization. She has published more than 30 research papers in peer-reviewed journals and has contributed to technical books also. In 2005, she started Samuchit Enviro Tech, a social enterprise that promotes environmentally sustainable energy and lifestyle products. Dr. Karve, who is managing director of Samuchit, has also invented an easy-to-use Samuchit carbon footprint calculator for urban Indians and conducts workshop on climate-friendly lifestyles, sustainable urbanization. She's also the founder, director of Urja Box LLP, a green startup from 2021. Dr. Karve is actually involved in national and international organizations working in the field of renewable energy, equitable, sustainable development, climate resilience, etc. She is a founder member and a member of board of director of Clean Energy Access Network, a registered society in India, and serves on a governing and advisory bodies of number of other national and international organizations. She's also the national convener of Indian Network of Ethics and Climate Change. She teaches the courses on sustainability, physics, big history at Symbiosis International University. Her work has been honored by several national and international awards, including World Technology Award in Environment category in 2005 by World Technology Network, New York, Sahyadri Hirkani Award in 2011 by Mumbai Doordarshan Television Channel, India, Vasundhara Award in 2014 by Kirloskar Vasundhara International Environmental Film Festival, Unsa Maza Zoka Award in 2050 in Environment category by ZTV Television Channel India. More prominently to say, she is a TEDx speaker and also has featured in number of national and international periodicals, publications, radio, television programs, and podcasts. So I suppose the words are not enough to explain her excellence and contribution in the field of science and technology. So not taking more time between you and respected honorable keynote speaker of today's national conference. On behalf from the organizing committee, I request Dr. Priyadarshini Karve ma'am to hold the session. Thank you. Over to Dr. Priyadarshini Karve ma'am.
Thank you, sir. And thank you to the management of the college for inviting me to participate in this multidisciplinary program. And that is what really caught my attention, because not many people are still focusing on the multidisciplinary aspects around climate change. So I hope I can share my screen. Just give me a minute. I hope the presentation is visible.
Yes, ma'am. It's visible.
Okay, so I'm going to focus primarily on discussing climate change impacts that are experienced in the Indian subcontinent, which actually has 7 countries as a part of this region. But before getting into that, just sort of a primer, just to remind ourselves as to why climate change is a problem and why we humans are responsible for it. So if we think about the planet Earth and its atmosphere, we are receiving our primary source of energy is the sun. And the solar radiation comes through the atmosphere, hits the surface, gets absorbed by various objects on the surface, and then some of the energy is emitted back as heat. But our climate has some constituents which are called greenhouse gases. Carbon dioxide is the main one in that. These gas molecules trap the heat in our atmosphere. And that is why Earth is a warm planet. And that's the reason actually why life has evolved on this planet and is thriving. So in a sense, this so-called greenhouse effect is essential for our existence on this planet. But today what has happened is the heat being trapped in the atmosphere, there is more heat that is being trapped in the atmosphere, and the average temperature of the planet has started increasing from that optimum value which was working great for us, particularly as humans. So currently the temperature of the planet is about 1 degree centigrade warmer than what it used to be before the industrialization of human civilization. And that kind of temperatures have been experienced on the planet a few million years ago. Humans evolved on planet Earth about 300,000 years ago. So the kind of climatic conditions that are currently existing on the planet have never been experienced by any humans before this. And these are sort of unprecedented times that we are living in. Now, why is this happening? To understand that, we have to understand the carbon cycle, and particularly the natural carbon cycle, where because carbon dioxide is the main greenhouse gas. So there are actually 2 carbon cycles. One is the geological cycle and the other is the biological cycle. In the geological cycle, carbon dioxide from the atmosphere dissolves in ocean. It becomes carbonate, and that is what forms soil and rocks and so on. Whenever there are volcanic eruptions, or even as an ongoing process, as the rocks are slowly eroding, slowly this carbon dioxide is getting released back into the atmosphere. So this is a very slow cycle. If you are tracking a particular carbon atom, then it may take millions of years for it to complete this cycle. The biological cycle, which set in after life evolved, and particularly after the evolution of photosynthesis happened in living organisms. This is the biological carbon cycle with which we are more familiar. Plants use carbon dioxide from the atmosphere to produce biomass, which feeds animals. Animals also eat other animals, and when both plants and animals die, their dead bodies decompose, and this carbon dioxide is released back into the atmosphere. This is a relatively shorter cycle, just a few hundred years or so. So these 2 cycles have been sort of maintaining a certain balance in the atmosphere and the surface of the planet, how the carbon is being exchanged between these two Earth systems. Sometime during the evolution of the life in the last about 4 billion years, there have been several instances when, for a variety of reasons, the conditions on the planet suddenly changed and a lot of living organisms suddenly died. Now, on a couple of those occasions, the dead biomass got buried under the Earth's surface. And instead of decomposing, it got chemically converted under high pressure and high temperature conditions into coal and petroleum. In the around 1850s, we started industrialization, and that is when really mass use of this fossil fuels started. And we started digging up this coal and petroleum, burning it, and that put additional carbon dioxide in the atmosphere, which for which there is no return path, because now the conditions on the planet are such that dead biomass doesn't convert into coal and petroleum, it gets decomposed. So no new coal and petroleum is being produced on the planet anymore. And therefore, there is a one-way flow of carbon dioxide, and that is what started increasing the amount of carbon dioxide in the atmosphere, and therefore the trapping of heat, and therefore the greenhouse effect, and therefore the increase in the average temperature of the planet. In addition to that, it is not just an effect of carbon dioxide, but there have been some other offshoots of our industrialization, and that is producing other pollutants which also happen to be greenhouse gases. So one of those is methane, which is produced in our industrialized agricultural systems, also various industrial processes. Nitrous oxides are produced as a pollutant in our internal combustion engines, the vehicles, for example. Hydrofluorocarbons. This is an interesting story that I'm sure everybody is aware of the problem with the ozone layer. Chlorofluorocarbons, these were chemicals being used in refrigeration systems. And from there, these molecules were leaking out, and that started impacting the ozone layer. Now, in order to solve this problem, CFCs were replaced by HFCs, hydrofluorocarbons. But HFC happens to be a greenhouse gas. So it has solved one global problem, but it is contributing to another global problem. There are several such pollutants which are also being produced, and these are also contributing to the overall greenhouse effect along with carbon dioxide. So this is what has been happening to the planetary system. And as industrialization is a human induced process, therefore this change in the climatic conditions, which has been happening very, very rapidly, this is also a human induced impact. Now, what are actually the impacts that are being felt locally at different points on the planet? One impact is obviously as the temperature of the planet increases, the water that is locked up as ice in the polar regions or in glaciers, that is melting, and there is a huge amount of water that is getting into the oceans. The oceans are also absorbing a lot of heat from the atmosphere, and it's a combined effect of these two things, because of which the sea level is now rising. Now, as it is, planet Earth has more water than land, and now the water is occupying more space, which means that the land area is now shrinking. Another important effect of these changes is that our weather engine is actually dependent on the conditions in the oceans. For example, there are cold and hot currents in oceans, and wherever this cold and hot water comes together, that is where cloud formation happens, and that is from there the rain pattern gets established across the planet. Now, what is happening is, with the sea becoming warmer and with the additional cold water coming into the oceans, all of these temperature patterns within the ocean are getting impacted. And that is why the rain pattern across the world is getting impacted, and other weather conditions are also getting impacted. This is being experienced in different ways in different parts of the world. Another effect, which is sort of a side effect of this disruption in weather patterns, is an increase in natural disasters. We are seeing more cyclones, more forest fires, more heat waves, as well as more cold waves. So in different places, different things are happening. Extreme weather events are happening. And what is now the trend that is being observed is that as the temperature has gone on increasing, since the visible impacts really started appearing since about 1970s or so. So last 50 years or so, scientists have been noting this, observing this, that the severity of all of these impacts goes on increasing with increasing temperature. And as we continue to put more and more greenhouse gases in the atmosphere, the global average temperature is slowly going up, and the impacts also are therefore becoming more severe, more frequent, especially in terms of disasters. And therefore everybody now sort of feels and experiences the climate change impact, especially in the last 20, 30 years. Nobody can now deny that the climatic conditions are changing, and therefore the weather patterns are getting disrupted. So this is on a global scale. What does the current research say? So Intergovernmental Panel on Climate Change. This is a global body of scientists as well as government representatives, which works under the umbrella of United Nations Framework Convention on Climate Change. And the role of IPCC is that from time to time, this group takes a review of all the scientific discoveries till that point in time around climate change. And they publish assessment reports which are supposed to guide policy making at the country level. So that's the overall role of IPCC. Now, IPCC has been producing assessment reports for several years now. The sixth assessment report, which came out about a year or so ago, that focused mainly on what is happening to the climatic conditions and what should we do for that. There is another report that is due at the end of this month, and some indications of what that report will contain are coming out. That report, interestingly, is going to focus on impacts and how do we deal with those impacts. So those of you who are in this meeting, please be on the lookout for release of this report on 28th February, which will give more details, latest knowledge about climate change impacts, which is the topic of this conference. These reports, the previous one and the upcoming one, collectively, two things are coming out very prominently. The Earth is now well on its way to be about 1.5 degrees warmer than the pre-industrial era. And that is going to happen by 2050. Now, this is something to think about, because in 2015, all the nations came together, all the governments of all the countries in the world promised to the entire humanity that they will do everything possible to keep this increase in the Earth's temperature limited to about 2 degrees centigrade by the end of the century. So 2 degrees centigrade warmer than the pre-industrial era is sort of the goal post. That is the target for 2100. And we are about to cross 1.5 degrees at the middle of the century itself. That leaves very little margin for the remaining 50 years. So this is a big concern. What will happen if we hit 2 degrees centigrade before 2100, the rate at which the temperature is increasing is the crucial factor here. It is because of this very fast, very rapid increase in temperature that is what is causing all the damage, because it is not giving us either biologically or industrially to adjust with the changes that are happening. And therefore we need to slow down the climate change impact, because reversing it is now not an option. We cannot go back to the pre-industrial temperature. So the only thing we can do is slow it down. If we fail to slow it down sufficiently, then the kind of impacts that will be experienced will be so damaging that it will lead to a collapse of our economic, political, and social systems. It will not wipe out humans from the planet, but it will definitely wipe out the civilization that we have built over the last couple of 100 years. So from that point of view, this first point is a big concern. And the new report that is coming up will sort of undisputedly show that the warming that has already happened, we are already at about 1 degree centigrade warmer than the pre-industrial era. And that warming is now irreversible. We cannot go back. So what should we do? We must achieve deep and rapid cuts in our GHG emissions by 2030. So this decade is very, very crucial. These 8-9 years that are in our hands, we really need to totally transform our technological systems in such a way that instead of going up year on year, our GHG emissions should start dropping, and pretty rapidly dropping by 2030. So we still have this room, we still have this opportunity to push this 2050 deadline towards 2100 for reaching that 1.5 degree mark. So it's a challenging situation, but still there is hope. But at the same time, because the warming that has already happened is irreversible, changes have already set in. We are now living with a new normal as far as weather conditions are concerned, and we just have to adapt to that, and we have to learn to live with that. How do we build our resilience to the various shocks that these changes are going to throw at us? That is going to be crucial for our survival from this point onwards. So basically then what these reports, the one that is already out and the one that is coming in just a few weeks, they are telling us that we need to tackle climate change on two fronts. What we need to do is, on one hand, we have to reduce our greenhouse gas emissions, which means that we have to shift to low carbon processes and products in all spheres of human activities, so that our annual greenhouse gas emissions, and I'm talking on a global level here, that year on year, it should be lesser than the previous year. Secondly, we need to adapt to climate change, and that is where actually the focus of this conference is, understanding the impacts and learning to deal with them. We have to shift to processes and products that are aligned with the new atmospheric and ecological conditions in all spheres of human activities. So it is like we are fighting this war on two fronts, and unless and until we recognize this, we will not start gaining on the problem. Right now what is happening globally is that there is a disproportionate amount of emphasis only on the first part. Everybody talks only about reducing emissions. Very few people, very few discussions are happening around how do we deal with the situation that we have now created and which is now irreversible. So, and especially for developing countries, actually, adaptation needs to be a bigger focus than mitigation, because our emissions anyway are not very high. But as far as India is concerned, we are in a unique situation, because we have both of these challenges very prominently attacking us. We are one of the top 5 greenhouse gas emitting countries right now. So that's something to think about, that India and China, both of these countries, we are the developed among developing countries, and both of these are very large countries with large populations. And that's the reason why, if you look at the annual emissions that are going in the atmosphere right now, China is at number 1 and we are at number 3. US is at number 2. So we are among the top 5 emitters, and therefore, of course, there is a lot of pressure on us internationally to reduce our emissions. And that's the reason why our government is primarily focused on this aspect, because of the international pressure. Now, who is responsible within the country for putting us in that rank? So one is obviously the energy sector. There are a number of carbon intensive industries. A whole lot of infrastructure is being built in India right now, and cement and steel are necessary for that infrastructure. But both of these are highly carbon intensive materials. Cities, urbanization is really happening very rapidly across the country. And as cities grow, they become hubs of greenhouse gas emissions. And of course, the agricultural sector is also a prominent contributor to the greenhouse gas emissions, primarily through uh, use of fertilizers, and also through the methane generation that is happening. But if you look on the other side, we are also one of the top 5 countries which are going to be hit by climate change impacts the most, climate vulnerable countries. And this is a very unique combination, because if you look at the other countries which are which are emitting very high amount of greenhouse gas, those countries are not suffering too much impacts. So that is an interesting factor there. If you look at the countries which are most vulnerable, which are suffering the most impacts, their contribution to greenhouse gas emissions is very low. But India is one country which is at a high level in both these lists. But again, if you look at what is happening within the country, which are the population groups which are suffering the most? It is mainly the fishing communities, traditional communities which are dependent on natural ecosystems like tribals, for example, subsistence farmers, because they are also dependent primarily on weather conditions. And even in the urban areas, urban poor are also highly vulnerable to facing these acts. So this is an interesting situation here, that the population groups which are responsible for the problem are different from the population groups who are going to suffer the most because of climate change. So this is an interesting political situation here, that at an international level, there is this developed country viewpoint and developing country viewpoint. But even within the country, we have those who are benefiting from emissions and those who are suffering from emissions. So there is this internal conflict also, that is a sociological conflict, economic conflict, and political conflict. And it's important to understand that when we figure out what we should be doing at a country level. So I'm just leaving this point here for you to debate in the conference, because again, and this is where I'm sort of stressing these points, because this is where the multidisciplinarity of the climate change problem comes into play. So let us move on now and focus on has been happening to the Indian subcontinent, which is actually bigger than India as a country. Now, here I sort of go a bit into geology, and this is something that most of you would know, that the India plate, the geological plate, uh, was in the southern hemisphere once upon a time, when all the continents were together in one landmass. When that landmass started breaking up, one piece, which also contained this India plate, broke off about 140 million years ago and started drifting towards the southern, towards northwards, towards the equator from the southern hemisphere. India plate has been the plate which has traveled the most in this process of breaking up and moving around that happened at that time. On its journey, it left behind some other pieces. It left behind Australia, it left behind Madagascar, and eventually, about 55 million years ago, this plate collided with the Eurasian plate, leading to the formation of the Himalayas and Tibet. Now, why am I talking about this? This northward push, of course, is still continuing, and that is why the Himalayan belt is so earthquake prone, and why the height of the Himalayas is still rising. But the reason why I'm talking about this is because this geological history is coming together now with climate change, because the kind of climatic conditions that we experience in the Indian subcontinent is because of this geological history. And it's important to understand this correlation, because then only we will be able to understand how climate change is now impacting our weather conditions. And that also explains why this region is one of the most climate vulnerable regions in the world. So one interesting thing that we should know and understand and acknowledge, that how water is distributed in the Indian subcontinent. Now, in the southern tip of India, there is a slope from west to east. And because of that, we see that the Western Ghats, rivers which originate in the Western Ghats, flow eastwards and empty in the Bay of Bengal. There are just a couple of rivers which flow westwards and go towards the Arabian Sea. If that was not the case, we will not have much water in the southern part of India. So the greening of the southern tip is because of this interesting slope from west to east. The Himalayan wall to the north of India also plays an important role in our weather conditions and overall in the way our ecosystems are. The monsoon it comes from the southern part, from southwest. The monsoon winds come, they move across the subcontinental landmass, and then they hit the Himalayas. And that turns back the monsoon winds, and that is how we get the rain twice. And that's also another reason why we do have water, and why this region is relatively greener than the surrounding areas. So the special monsoon cycle that we experience is a gift to us from the Himalayas. And why this is important, because if you look at the global map here, this is South Asia, which is the Indian subcontinent, and this is the Himalayan belt. Now, under the Himalayan belt, you see that there is green. But if you go to this side, to the west side, this is entire desert. Right from Sahara to Arabian Peninsula, this was entirely desert, but the tip of the desert ends in Kutch region in India. And then suddenly you have this green patch. This is the impact of the Himalayas, and we have to understand and acknowledge that. So keeping that in mind, if we look at the impacts experienced by this entire subcontinent, which, as I said, has 7 countries as a part of it, If you look at the Arabian Sea coast, this is a phenomenon both for India and Pakistan. What is happening is as the oceans are warming, fish populations move from south to north. Now, Arabian Sea ends at the top, so there isn't much movement possible beyond that. And that is why if the temperature keeps on increasing, we will see more and more fish species which are sensitive to ocean temperatures. They will go extinct because there will be nowhere else for them to keep moving north. As the seawater level is increasing, there is submergence and erosion, and that can prove really crucial for some of the commercial ports. What you see in the photograph is a commercial port that Pakistan is developing. Now, look how close it is to the mountain. If the land is getting submerged, the existence of this port really gets threatened. We are also increasingly seeing more cyclonic activity in the Arabian Sea. Now, this has been a very, very rare phenomenon for people on the West Coast. And in Konkan, you have particularly experienced this over the last few years. Occasionally, once in a blue moon, some cyclone would come close by and then drift away. But now, especially in the last 2 3 years, we are seeing not just one but sometimes multiple cyclones coming in the same monsoon season. This increases the vulnerability of seaports, which have become important economic centers. Mumbai for India, Karachi for Pakistan. These became important commercial centers because the Arabian Sea was relatively less impacted by cyclonic activity. But now that is changing, which is a huge impact for international commercial activity also. If you look at the East Coast, which is a problem for India and Bangladesh in the Indian subcontinent, this area has always been prone to cyclones, but now again, the number of cyclones is increasing and the devastating impacts of the cyclone are also increasing. What you see in the photograph is a Sidr cyclone, which really hit Bangladesh badly just a few years ago. Erosion and submergence is a problem on this side also. Bangladesh is actually is at number 1 as the most vulnerable country in the world to impacts of climate change. 10% of its landmass is likely to go underwater because of rise in sea level, and it is a densely populated country, and it keeps on getting battered by cyclonic activity. As it is, there are parts of Bangladesh where the land has always been shifting around, so that effect is also that phenomenon is also getting impacted, and that is really playing havoc with their agricultural systems and so on and so forth. So the plight of Bangladesh is really very, very serious in the Indian subcontinent. Now, if we look at the northern frontier, which is Pakistan, India, Bhutan, and Nepal, all of these are this is the Himalayan and northern belt. Um, right now, as the glaciers are melting away, currently we are experiencing a lot of flooding in this area. But later on, what is going to happen is, as the glaciers totally disappear, the big rivers in the northern part, which is Ganga, Brahmaputra, Sindhu, these rivers which originate in the glaciers, they will lose their water source, and we can right now only imagine what kind of havoc that is going to cause. I mean, imagine a river like Ganga going dry at least for a few months in a year. That will play havoc with water availability, with agriculture. As far as India is concerned, our bread basket is in the north because of the because of the perennial rivers in the North India. That food security is going to get threatened. And this region is anyway geologically unstable. So there are already high risks of natural disasters related to earthquakes, and now there is a higher risk of natural disasters related to climate change. So this is becoming a hugely disaster prone area, and frankly, any large infrastructural project in this region is actually suicidal. It is highly unadvisable by any scientific, from any scientific angle. And therefore, we really need to rethink development priorities. All of these countries really need to rethink development priorities and infrastructure building in the Himalayan region. If we think about central and southern India, we are, again, this is a phenomenon that Maharashtra state is also experiencing. Cycles of extremely wet and extremely dry spells. So you have drought followed by floods, drought followed by floods. Especially Marathwada has really been hammered by this kind of weather impacts. There is an increase in lightning strikes during monsoons, and this is also linked with overall changes in the weather conditions. We are seeing more frequent and more intense heat waves now across central and southern India. In the summer season, the weather becomes very, very dry and very, very hot, and that leads to forest fires. So instances of forest fire are also increasing across this region. So it's not just that the boundary regions are facing problems, but even the central parts of the subcontinent are facing problems. And think about the islands. Sri Lanka and Maldives, these are countries, Lakshadweep, Andaman, Nicobar, these are parts of India, but all of these are islands in the Indian subcontinent. Several of these land masses are facing submergence because of rising sea level. Their coastal ecosystems are suffering huge damage. And these islands have, tourism has been one of their main economic mainstay. But as the ecosystems get damaged, the tourism also gets impacted. And Maldives particularly, the warming that has already happened, there is no way to save Maldives now. In another 2-3 decades, that entire country is going to disappear. It will be submerged underwater. So if you want to visit Maldives, now is the time to go and see it, because in the next 30-40 years, it will be gone because of the warming that has already happened, which means that nothing can now save this country's existence. So this is the kind of things that are happening across the Indian subcontinent, and that is why this is a highly vulnerable region for impacts of climate change. Just to give you a human aspect of this impact, this is data from India. Because of the coastal and island impacts, nearly 45% of India's population is in this region. So their livelihoods, their way of life, their residences themselves are going to get impacted. If you look at the Himalayan belt, nearly 40% people depend on the water flows in this region. All of they will suffer huge water scarcity. And if you look at the nationwide impacts, nearly 90% of India's population is going to be directly impacted by climate change. And the story is not different for other countries. In fact, it might even be worse for some of the other countries because of their small size, like Sri Lanka and Bangladesh, Maldives, I already talked about. So this is the kind of a situation that scientific analysis is telling us that we are facing. So what do we do in this situation? Why should this be talked about in public fora? This is no longer just a matter of scientific research and projections. This has to become conversations in people's homes, in schools, in colleges, in businesses, in public spaces. Because the entire Indian subcontinental region, I hope I have emphasized this point enough, that it is facing extreme vulnerability, high population density, shrinking land mass, which is going to further increase the population density. See, population density is total population divided by available land area. Now, population is increasing and land area is reducing. So population density is increasing more because of this dual effect. And water availability is becoming more and more uncertain in this entire region. So this is really a recipe for disaster. And what we are going to see is a huge number of climate refugees. Millions of people will be forced to move away from where they are right now because of these climate change impacts within the country as well as across country borders. I mean, think about it. If Maldives is going to entirely submerge, where are those people going to go? They will have to move to some other country. Bangladesh, where are the people going to go? So there is an existing political volatility in the region, and that is going to become even more volatile because of climate refugees. And this is again a political scenario that nobody seems to be talking about, nobody seems to be anticipating, nobody seems to be trying to figure out how do we solve this. This, according to me, is a ticking time bomb for the Indian subcontinent. Urgently, each country needs to focus on adaptation, to try and reduce the risks, to try and reduce the damage caused to vulnerable population groups to the best extent possible. Climate proofing wherever it is possible. For example, can we change our agricultural systems to suit the new reality of water availability and weather conditions, which will climate proof the agricultural sector? We really need to do a soul searching on our developmental choices, the way our urbanization is moving. And this is across all these countries. This entire region is a developing region, and big cities are coming up, big infrastructure projects are coming up. How are these buildings, these roads, these flyovers, these airports, how are they going to interact with the local climate change impacts? Unfortunately, across the Indian subcontinent, we really have a very poor record of even doing environmental assessments. Nobody is at this point in time doing a climate assessment, how infrastructure is going to interact with climate change. We really, really need to get into that kind of mode of thinking. We need a collective regional response here. We have to realize that the global planetary kind of effect doesn't recognize national boundaries. National boundaries are artificial constructs that we have created. The planetary system only recognizes ecosystem regions. And from that point of view, the Indian subcontinent, which has evolved as a very unique ecosystem region, thanks to its geological history and because of the Himalayas, etc., we really need to transcend our national level disputes and work on a collective regional response. Can this happen given the political realities is really the big question. But we have to understand here that the political boundaries between nations are just about 100 or a few 100-year old. The cultural boundaries, the religion boundaries and other cultural boundaries, these are at best a few 1,000-year old, but our regional history is a few million-year old. So that has to take precedence somewhere. And in a way, I feel that we in India have a greater responsibility, because among all these 7 nations, we are the largest. We are also the most robust democracy. And in a democratic system, it is the people who drive the democratic agenda. And therefore, as people, we will have to come together and really think through what kind of political agenda we want in our region, in the Indian subcontinent. We have to think regionally for our own survival. I mean, it is a matter of survival now. From that perspective, we have to change the political discourse. We have to move the political discourse of the entire region towards developing a regional response to climate change, towards cooperation, collaboration, conversations. And that responsibility largely falls on the shoulders of you and I, who are citizens of India. So I'll stop here and would be happy to answer questions. So I'll stop here, and thank you very much. I would be happy to answer questions. I'll stop sharing the screen.
Thank you, ma'am. Thank you very much. Questions are there? Please. Okay. Thank you, ma'am, for your zestful direction. You have traveled us from the realms of gold with your deep insights into the burning issue of climate change. Thank you very much.
Hello, ma'am. Hello.
Yeah.
Yes, yes.
Myself, Nilkanta Bhalerao. I'm the assistant professor of microbiology from Karve Bhosle College, Guwahati. Ma'am, my question is regarding with the biofertilizers and the newer microbial technology. So how the biofertilizers, use of biofertilizers or the newer microbial technologies included in the fertilizations. So is it it is an answer to the climate change, sudden climate changes?
Yeah. So climate aligned agriculture requires various interventions, and one of those is trying to find replacement for chemical fertilizer, because we can't really afford for the productivity to go down. We need to feed a large population across the world as well as within the subcontinent. So how do we maintain agricultural productivity and at the same time reduce the greenhouse gas emissions from agriculture, which major contributor to which is chemical fertilizers. So organic fertilizers, biofertilizers, and more than that, actually making intelligent use of the symbiotic relationship between soil bacteria and plants. Understanding this relationship and making use of this relationship for our benefit. Bacteria we have been using very smartly for a variety of things, like fermentation, for example. Similarly, in agriculture also, we have to put bacteria to work and thereby reduce external energy input. That is one strategy which needs to be followed, and a lot of interesting work is there for happening. It's not really my field of work, but yes, that is the approach to take to reduce greenhouse gas emissions from agricultural sector.
Okay,
There is a question in the chat box.
Yes.
What is the connection of the increase in lightning incidences in recent years and the climate change?
So that is related to some extent with the way the monsoon winds are moving and the kind of conditions, because it's a combination of factors, like what is the humidity, how the clouds are moving, even in summer season we also experience static electricity build up between. So if you are wearing a synthetic material and you get up from a plastic chair, you see that static electricity effect. So the dry weather in the summer season leads to build up of static charges, and when the monsoon comes, electricity is basically release of that charge. So that is somewhere linked with this phenomenon.
We have another question, ma'am. How can we contribute in green gas generation by using of fertilizers in agriculture?
Green gas generation means, if you are talking about biogas generation, or
the question is,
or are you talking about greenhouse gas?
Yes,
Savita ma'am, can you
Yes, ma'am. It may be related with the greenhouse gases.
Yes.
By the synthesis of chemical fertilizers, greenhouse gases emitted.
Yeah.
Yeah.
So I think I already answered that if you reduce use of chemical fertilizers, then that is going to reduce one component of greenhouse gas emissions from agricultural sector. So that has to be a priority, definitely. But at the same time, we have to be careful that we don't allow the agricultural yields to drop. Otherwise, we are going to create food insecurity. So this is a very complex and delicate balance that has to be achieved.
Yes, exactly.
Yes, ma'am. Thank you very much, ma'am. Thank you. Now,
Hello. Hello.
Yes.
Hello.
Go ahead, sir.
Yes. Now we are shifting forward to the first plenary session, and we are privileged to have Honorable Dr. P.S. Kamble sir, Professor, Shivaji University, Kolhapur. This session will be chaired by Dr. Vishal R. Tomar, Associate Professor, MMK College, Bandra, West Mumbai. May I call upon my colleague, Mr. V.D. Mahajan, to introduce today's resource person, Honorable Dr. P.S. Kamble sir. Over to Mahajan sir.
Mahajan sir.
Hello friends, on the occasion of today's national level conference,